Hi, welcome to Hashtag Math. We're going to do 3 more examples on derivatives of trigonometric functions. Okay, we're going to derive y equals x cubed sine x cosine x. This is the multiplication of 3 functions. So what we do is we group 2 functions and apply the product rule. In this case, I'm going to group my functions like this. So I'm going to see my product rule with this product here. Let's apply the product rule. The derivative of y is going to be keep the first and derive the second. So the derivative of sine x times cosine x plus derive the first and keep the second. And you see, now here we have again a product and we again have to use the product rule. So we keep x cubed and do the product rule here. Keep the sine, derive the cosine, plus derive the sine, keep the cosine. For the second term, we can just derive x cubed to get 3x squared, and that's sine x cosine x. Now it's just derive and simplify. So this is x cubed times sine x. The derivative of the cosine is negative sine x plus the derivative of the sine is the cosine times cosine x plus 3x squared sine x cosine x. Now let's multiply, combine, see how we are going to leave our answer. So this is x cubed. Sine x times negative sine x is negative sine squared x. Cosine x is cosine squared x plus 3x squared sine x cosine x. Now leaving that parenthesis there, that negative sign, I don't like it. So I'm going to distribute the x cubed and we get the answer. X cubed cosine squared x minus x cubed sine squared x plus 3x squared sine x cosine x. And it's ready. In the following example, we have a quotient. You can, of course, try to do trigonometric identities, like cotangent would be cosine over sine, but I tried it, that's not going to help. We go better if we just apply the quotient rule, straightforward. So let's apply the quotient rule. The derivative of y is going to be low d high minus high d low. Square the bottom and away we go. Now we derive 1 plus cotangent x times the derivative of the cotangent, which is negative cosecant squared x, minus cotangent x, and the derivative of 1 plus cotangent x is again negative cosecant squared x, all over 1 plus cotangent x squared. Now you see that negative cosecant squared repeating here and here. Well, I'm going to factor negative cosecant squared from both terms. And we're left with 1 plus cotangent minus cotangent x over 1 plus cotangent x squared. The cotangents cancel out, and the answer is going to be negative cosecant squared x over 1 plus cotangent x squared. And we're done. In this example, we want to find a tangent line to a function that involves a sine function. So as always, we start deriving. As you can see, we have a product, so we apply the product rule. The derivative of y is going to be keep the first, derive the second, plus derive the first, and keep the second. X, the derivative of the sine, is the cosine, plus the derivative of x is 1, so this is just sine x. So this is x cosine x plus sine x. So what we got here is the derivative of y with respect to x. And this is my derivative function. It tells me the slope of the tangent line at any x. The problem is asking to find the tangent line at pi over 2, so we need to find the derivative at pi over 2. And that is just going to be pi over 2. Just insert pi over 2 there in the derivative. So we get pi over 2 cosine of pi over 2 plus sine of pi over 2. Cosine of pi over 2 is 0 and sine of pi over 2 is 1. So the slope of the tangent line is going to be 1. To find the equation of the tangent line, we need the point of tangency. And we just evaluate our original function at pi over 2. So my y at pi over 2 is going to be just pi over 2 sine of pi over 2. And sine of pi over 2 is 1, so this is pi over 2. So the point of tangency is going to be pi over 2 for x, and we found pi over 2 for y. Now we use the point-slope form of the line, where this is x1, this is y1, and my slope is 1. So the formula is y minus y1 equals mx minus x1. And we just plug in the numbers. We get y minus y1 is pi over 2 equal m, which is 1, times x minus x1, which is again pi over 2. Distribute and move the pi over 2 to the other side, and we get y equals x minus pi over 2 plus pi over 2. The tangent line is the identity function, and we're done. Thank you.